The question that I have is, what are the equilibrium equations that can be used in 3D analysis of rigid bodies? Now a little bit about the equilibrium equations. So here are the equations we've been using in 2D analyses. So typically you can write down a force equation in the horizontal direction, force equation in the vertical direction, and a moment equation about any point on the plane, right? So there are a total of 3 equations you can write down. As we have seen in the 2D section, we can use these equations or any combination of these. In 3D, there are 6 equations that you could write down. You can write down 3 force equations, one in each of the 3 coordinate directions, x, y, and z. In addition, you can write down 3 moment equations, one about each of the 3 coordinate axes, x, y, and z. In 2D, we know we can write down moment equations about any point, right? The corresponding thing in 3D is that you can write down moment equations about any line parallel to these coordinate axes. Like for example, I can write down a moment equation about the x-axis or any line that is parallel to the x-axis. And similarly, you can write down a moment equation about a line parallel to the y-axis and about a line parallel to the z-axis. Just as in 2D, you can use any combination of these. And finally, you can only write down a total of 6 equations in 3-dimensional analyses. One final comment about 3D analyses is that you can write down a moment equation about any arbitrary line, not necessarily a line with x, y, or z axes, but we won't do something like that in this course.